Ever wonder, like, how those periods of just crazy scientific progress happen?
Yeah,
Like, why were the early 1900s such a boom for physics?
right.
Well, we're going to deep dive into that today.
Okay.
Using this letter from Alessandro Rizzo.
Okay.
He's a researcher at Chiodia Labs.
Interesting.
And get this,
Mm.
it's their sound meets light department.
Wow, that
Well,
sounds like something out of science fiction.
totally.
Yeah.
So Rizzo, he's really fascinated by what made that era so special.
Mm-hmm.
You know, you've got Einstein, Bohr, Curie.
Right, right.
It's like, how are there so many brilliant minds all making these huge discoveries at the same time?
It's pretty remarkable. And Rizzo's letter really gets at what made it so fertile,
Right.
for all those breakthroughs. And
Exactly.
he offers a lot of insights that we can still learn from today.
Yeah, he uses this really cool analogy, like a garden of minds,
Okay, yeah.
where all these physicists were kind of like flowers blooming all at once,
Mhm.
just tossing ideas back and forth.
Right, cross-pollinating. Yeah, it really gets at the collaborative spirit back then.
Totally. So
Yeah.
it wasn't just like a random coincidence
Mm-hmm.
that relativity and quantum mechanics out of this kind of environment.
Yeah, that's what's so interesting about this. See, it wasn't just about individual brilliance.
Yeah.
It was about how all these minds work together. Like they were constantly challenging each other, debating, building on each other's work.
Okay, so it wasn't just about one person being a genius. It
Exactly.
was the whole scene.
Rizzo argues that the whole scientific landscape back then was just different.
Hmm.
Less about getting credit for yourself,
Mhm.
more about everyone understanding things together.
Okay.
They weren't worried about publications or impact factors.
Right.
It was all about the shared mission to unravel the mysteries of the universe.
Okay, I get that collaboration's important,
Hmm.
but wasn't Einstein, like, kind of a lone wolf?
Oh, that's a common misconception. Einstein, well, yeah, he was a genius, but he was also super engaged with the whole scientific community,
Oh, interesting.
exchanging ideas with his peers all the time, going to conferences, refining his theories based on feedback and debates.
Mhm.
Even his most groundbreaking stuff was shaped by that whole intellectual environment.
So you're saying that even someone as brilliant as Einstein, like, he still needed that back and forth?
Totally. Imagine if he'd just been off on his own, just focused on his narrow little research,
Yeah.
without all the input and challenges from other brilliant minds.
Right.
You think he would come up with those radical ideas?
Probably not.
Those that challenged, like, everything we thought we knew about space and time.
Good point. But I'm still a little skeptical.
Okay?
Don't we need some competition in science to push things forward?
Mm-hmm.
And what about, like, individual brilliance?
Sure.
Not every discovery happens because people are working together, right?
You're totally right to question that. And Rizzo acknowledges that too. I mean, throughout history, we've had amazing lone geniuses, right? Newton, Euler, Gauss,
Yeah.
Da Vinci even. They
Right.
made huge strides working pretty much solo.
Yeah, that's true. Like, Newton basically invented calculus while stuck inside during the plague.
Exactly. So it's not so black and white.
Right.
Both collaboration and individual brilliance are key for scientific advancements.
Okay.
The key, according to Rizzo, is finding a balance.
Okay. I'm starting to see where he's going with this. So what does Rizzo think we should be doing differently today?
Well, he's not saying we should try to perfectly recreate the past, but we can definitely learn from it.
Okay.
He points out a few key areas where we've kind of strayed from what made the early 1900s so great for breakthroughs.
Okay, so let's unpack those. What's the first one?
He starts with the overemphasis on quantitative metrics in modern science.
Okay.
All this pressure to publish, get cited, chase those numbers.
Yeah.
He thinks that pushes researchers towards just churning out lots of papers
Wow.
instead of doing that deep contemplative work.
Okay, so it's like we're rewarding the appearance of progress.
Yeah, exactly.
Over actual, breakthroughs.
Mhm.
But how do we evaluate research then?
All right.
I mean, we need some way to measure success.
Yeah, you're right. It's the tough one.
Yeah.
And Rizzo knows that metrics have their place.
Yeah.
But he thinks we've become way too reliant on them.
Okay.
We got to find a balance between the quantitative stuff and qualitative assessments that look at the depth, the originality, the potential impact of the research.
So it's not about ditching metrics altogether,
Right.
but just being more thoughtful about them.
Exactly. And it's also about, valuing research that's driven by pure curiosity.
Mm-hmm.
Even if it doesn't have like an immediate practical use or make a product you can sell.
Right, that's a tough one.
Yeah,
It seems like everyone wants to see results right away.
right. And that kind of leads us to another problem that Rizzo talks about,
Okay.
hyperspecialization. He thinks that by focusing more and more on these narrow fields of study, we're actually limiting collaboration.
Right, yeah.
You know, that cross-pollination of ideas that was so crucial back in the early 1900s.
Yeah, thinking about Einstein and how he drew from math, philosophy,
Mm.
makes you wonder about all the silos we have in research today.
Absolutely. Imagine if Einstein had been told, like, nope, you gotta stay in your relativity lane.
Yeah.
You think he'd been able to make those connections?
Probably not.
Doubtful.
Okay, so we've got too much focus on metrics,
Mm-hmm.
and hyperspecialization is limiting creativity.
Yeah.
What else does Rizzo think we can do to, like, create a better environment for these big breakthroughs?
Well, he believes that promoting open access to research
Okay.
and fostering more dialogue between disciplines
Mm-hmm.
are super important steps toward having a more collaborative and vibrant scientific community.
Yeah, I can see how that would help. But how do we actually put those ideas into practice?
Right. Yeah. It's a great question.
Stay tuned, folks. We'll dig into that in part 2 of our deep dive.
So I think it's time to kind of explore how we actually put those ideas into practice.
Yeah.
It's one thing to point out problems.
Right.
It's another to actually fix them.
Exactly. And it can feel really overwhelming to
Yeah.
think about changing, like, the whole system of science.
Right.
Where do we even start?
Well, Rizzo suggests that we start by changing how we think about things.
Okay.
Like, instead of chasing publications and grants, we should ask, what am I really passionate about solving? Like, what questions keep me up at night?
So going back to that, like, original motivation,
Exactly.
that curiosity,
Mhm.
that
It-
probably got us into science in the first place.
Right. And fostering that same spirit in the next generation,
Yeah.
like encouraging young scientists to ask those big questions,
Yeah.
to think across different fields, and to see the value in research for its own sake, not
Yeah.
just for the metrics.
That makes sense. But I imagine there's still a lot of pressure on young researchers
Oh, yeah,
to publish and get those grants.
for sure, especially in today's academic work.
Right. It's so competitive.
Yeah. But I think we can start to shift that by being better mentors,
Okay.
encouraging students and early career researchers to pursue work that they actually find exciting,
Mhm.
even if it doesn't fit neatly into, funding categories or what journals want to publish.
So being a little more daring in our choices
Exactly.
and encouraging that in our students.
Right. And this is where I think open access is really important.
Okay. Yeah.
By making it easier to share knowledge, we create a much more inclusive and collaborative community.
I'm all for open access, but wouldn't that make it harder to track all those metrics?
Uh-huh.
How would we evaluate research if everything's freely available?
Right. And that's definitely something we need to figure out
Yeah.
as we move towards a more open system.
Mm-hmm.
But I think the benefits outweigh the challenges.
Yep.
Imagine a world where anyone can access the latest findings,
Right.
no matter where they are or how much money they have.
Yeah, that would really make knowledge available to everybody.
It would. But wouldn't it also create this huge flood of information?
Yeah, that's true.
Like, how would researchers even keep up with everything?
Right.
Well, that's where we need better tools.
Okay.
Things like search engines, curation platforms, maybe even AI
Mhm.
to help us sort through it all.
Right.
But it also makes us rethink how we use and share knowledge.
Okay.
We can't just passively read everything that comes our way.
Yeah.
We have to actively seek out the information that's relevant to us.
So being more discerning about what we consume.
Exactly. And maybe relying more on trusted networks,
Right.
colleagues, to filter the noise.
Yeah, that makes sense. It also ties into, like, the importance of talking to people from different disciplines,
Right.
like breaking down those silos.
Yeah, we need to actively seek out people who have completely different perspectives.
Right.
It reminds me of what we were saying earlier about Einstein,
Yeah.
getting inspiration from math and philosophy.
Yeah, those different pieces are starting to fit together now.
Right. It's all connected.
Yeah.
But we have to be proactive.
Okay.
Go to a seminar in a different department,
Mm-hmm.
talk to someone from a different field at a conference,
Yeah.
read journals outside of your usual area.
So it's about being more adventurous,
Exactly.
stepping outside our comfort zones,
Hmm.
and engaging with ideas that might be unfamiliar.
Right. You never know what you'll discover.
Right.
It's like cross-training for your brain.
I love that. Yeah.
Mhm.
So besides being more open and adventurous,
Mm-hmm.
is there anything else we can do to create this kind of, like, intellectually stimulating environment?
Well, I think we also need to think about how we communicate science to the public.
Okay.
We need to do a better job of explaining how science works,
Hmm.
the importance of curiosity-driven research,
Right.
the value of long-term thinking.
It's about helping people understand that science isn't just about, making gadgets or cures.
Yeah,
It's about understanding the universe and our place in it.
exactly. And it's about celebrating the wonder of science.
Yeah.
Even if it doesn't have an immediate practical use.
Right.
We need to get people excited about the world around them and to
Yeah.
see science as this journey of exploration.
Yeah.
Yeah.
Talking about all this, I keep thinking back to that image of the early 1900s
Hmm.
as this vibrant, intellectually charged time.
Yeah.
It makes you wonder what those conversations were like.
Yeah.
All those clashes of ideas that led to so many breakthroughs.
Imagine being a fly on the wall at one of those Solvay conferences
Right.
where all the leading physicists got together to
Yeah.
debate those big questions.
Can you imagine the energy?
It must have been amazing. I mean, I know not every debate ended in a breakthrough,
Right.
but they all contributed to this collective understanding,
Yeah.
a shared sense of purpose, a drive to really push the limits of what we know.
Yeah. It sounds like a really cool blend of serious intellectual work
Mm-hmm.
and just playful curiosity.
Totally.
They weren't afraid to challenge each other,
Right.
but it also seemed like they really enjoyed it.
Yeah. I think that's a good lesson for us today.
Mm-hmm.
We need to create spaces where people feel comfortable sharing ideas,
Right.
even if they're unconventional or controversial.
So we need to see debate as a productive part of the process.
Exactly. And remember that the pursuit of knowledge isn't a solo mission. It's a team effort.
Right.
It requires open minds, a willingness to challenge what we think we know, and a commitment to finding the truth.
I like that. It's like we're all working together
Mhm.
to build this cathedral of knowledge.
Yeah, and the cool thing is that the cathedral's never finished.
Right.
It's always evolving and expanding,
Yeah.
reaching for new heights.
Okay. So we've talked about changing how we think about things,
Mm-hmm.
embracing open access,
Yeah.
talking to people from other fields,
Right.
communicating science in a better way.
Mm-hmm.
Are there any concrete steps we can take in our everyday lives,
Yeah.
to make this happen?
Well, I think it starts with each of us being aware of our role in this whole thing.
Mm-hmm.
We need to be mindful of how we treat our colleagues and students.
Yeah.
How we evaluate research.
Right.
How we share what we find.
Mm-hmm.
And how we stand up for science in the bigger world.
So it's about making conscious choices
Exactly.
that align with those values,
Mhm.
like curiosity, collaboration, open inquiry.
Right. All those small actions can really add up.
Yeah, that makes sense. As we're talking, I keep thinking about Rizzo's last question.
Mm.
What if we could go back in time and talk to those minds from the early 1900s?
Oh, yeah, that's a good word.
What would we ask them?
Right.
And what would they ask us?
It really makes you think
Yeah.
about the world we've built.
That's a great place to pick up when we come back for the final part of this deep dive. Okay, so we left off with that question from Rizzo about talking to those brilliant minds from the early 1900s.
Right.
Really gets you thinking about what they'd say about science today.
It does, yeah.
What would they be impressed by?
Mm-hmm.
What would they find strange?
It's like looking in a mirror,
Yeah. I bet they'd be amazed by how much we know now.
Oh, absolutely.
The Human Genome Project,
Right.
the Higgs boson,
Mm-hmm.
the James Webb Telescope.
It's incredible.
Mm-hmm.
It's mind-blowing.
Totally. But I also think they might be a little cautious.
Oh, interesting.
Have we been so busy gathering all this data
Yeah.
that we've lost sight of the big picture?
Mm.
Are we still driven by that same curiosity?
That's a good point. It's like we're so good at answering questions now
Right.
that we've forgotten how to ask them.
Exactly.
Maybe they'd remind us that the best discoveries
Mm-hmm.
often start with a simple why.
Totally.
Like a kid asking about the world. Yeah. I think they'd also be really interested in the ethical side of things.
Oh, for sure.
They saw firsthand how technology can be used for good and bad.
Right. They lived through those huge advancements,
Mm-hmm.
but also the world wars, the atomic bomb.
Exactly.
They really understood that double edge.
Yeah. I think they'd push us to ask not just, can we do this,
Yeah.
but should we?
Mm-hmm.
Science isn't inherently good or evil.
Right.
It's a tool.
And like any tool,
Mm-hmm.
it can be used in different ways.
Right.
Makes you think about all the debates we have now
Yeah.
about AI, genetic engineering, climate change.
Big stuff.
We have so much power.
Yeah. Are we using it wisely, though?
That's the question.
Are we thinking about the long-term consequences?
Those are exactly the kinds of things they'd want us to grapple with.
I think so.
They'd urge us to be humble, responsible, and
Yeah.
really aware of how these technologies could impact humanity.
And the planet.
So it's not enough to just keep pushing the boundaries of knowledge.
No.
We have to think about the ethics, too.
Exactly. And that's what Rizzo is getting at.
Yeah.
It's not just about changing rules or funding. It's about having the right mindset, a way of doing science that balances ambition and humility,
Okay.
curiosity and caution,
Yeah.
individual brilliance and collective wisdom.
I love that. It's like he's laying out a plan for a new kind of scientific enlightenment,
That's a great way to put it.
taking the best of the past, but looking ahead to the future.
And it's not just for scientists.
Right.
It's for anyone who cares about how science shapes the world.
So, to wrap up this deep dive,
Yeah.
we leave you with that final question from Rizzo.
Mm.
If you could talk to Einstein or Curie or Bohr,
Right.
what would you ask them?
Good question.
And what do you think they'd ask you?
Take some time to think about it.
Yeah.
You might discover something new,
Or see things from a different angle.
or even rediscover that sense of wonder about science.
Thanks for joining us on this journey.
Yeah, thanks for listening.
Keep asking those big questions and stay curious.